Our next speaker is Sharon Pizzell. Just kidding. Our next speaker is Sharon Pazel. And so, as I mentioned earlier, Sharon is a PhD student at Utah State University, did a lot of work on this program. My funny story about Sharon. There is a good one. So we did this hazing study, and part of it was having us out there encourage the public to haze, and it was amazingly difficult. For us introverts, Sharon and I are both introverts, it's really hard to interact with the public. Well, so we do this thing, we're halfway through, and there's a lot of controversy. People are not happy with what we're doing. And this little old lady, about 70 years old, walks up to Sharon and goes, "How would you like it if I hazed you?" And I laughed so hard. I was just so happy it wasn't me on the receiving end. Anyway, so Sharon is going to talk about coyote ecology. She's got a lot of cool data, and then we'll take a break afterwards.
Okay, so this is really unfair. This is the second time I've had to follow Marianne in a talk. It's not fair because she's so exuberant and I'm not. The last time people started walking out when I started talking. So I believe I have the longest talk of the day, and I have a lot of topics to cover, so we'll get started. This is an outline of what I'll be talking about, mostly involving the collared coyotes. So I'll talk about how we captured and monitored coyotes. I'll go over some of the causes of deaths of our collared coyotes. In particular, I'll go over in more detail rodenticide poisoning, one of the causes of death. I'll briefly go over some of the results of our disease testing of the collared animals. I'll talk about the home ranges that we identified of different coyote groups. I'll go over habitat use and selection. We did a diet study, so we have preliminary results on that I'll talk about. And then finally, I'll wrap up with an estimate of the coyote population size in Denver. So the first thing I wanted to show you was this map of the Denver urban area. I'll be showing you a lot of maps with this polygon. This is a polygon defined by the U.S. Census Bureau from 2010 of the Denver urban area. And so the future maps I'll show will have this polygon outlined in blue. And so we'll first talk about the capturing process of coyotes. We captured them from April 2012 to May 2013, and that was not continuous. We took a break in summer of 2012 because we didn't want to catch pups. We just wanted to catch adults. And we used padded foothold traps and snares, and we concentrated our trapping in natural areas that had less human activity. And at most sites, we covered the traps up during the day so that we wouldn't catch dogs, and then opened them back up at night. And so we've attached a trap tranquilizer device, which is this TTD, and it's this little device right here attached to the trap. And so that contains a drug, and so the idea is that when a coyote is caught in the trap, he'll bite on this TTD, which will cause him to ingest the drug, which will cause him to calm down and not fight the trap so much and reduce injuries. And so we use that on all of the traps. We also used a trap alert device, which is this device here. It was attached to the trap with a cable with a magnet on it. And so when the trap closed, the magnet would pull off, setting off the trap alert device, which would then send a text message to the cell phone of the person on duty that night. And so we would get the text message, it would say your trap is closed, and then we could go out there immediately to work up the coyote. And that way, the coyote doesn't have to stay in the trap for hours and hours. So when we started working up the coyotes, we took a lot of measurements. We weighed the coyote, sexed them, aged them based on tooth wear. We took some body measurements, assessed general body condition. We took body temperature, and then we took blood, which was used in disease testing, which I'll talk about in just a second. We then attached a GPS collar. This is an example of a collar here. And we also attached uniquely colored ear tags to the coyote so that we could identify a coyote in the field just by looking at the colors of the ear tags. So we monitor the coyotes on a weekly basis using a Yagi antenna and receiver, which is what I'm holding here in this picture. 7 of our collars were remote downloadable, which meant if I got within a certain distance of the collar, I could download the data from the collar using a receiver that I had. But most of our collars were store on board, which meant we had to wait until we got the collars back before getting the data from them. And the way we got them back was that every collar had a drop-off mechanism attached, which is this device here on the collar. And so the way that works, the collar was programmed to drop off at a certain date and time. And at that time, it would just, the mechanism would detach from the collar would fall to the ground, and then I would just go out to the field to find the collar. So we captured and collared 32 coyotes, 18 males and 14 females, and we only received data from 24 coyotes, 14 males and 10 females. So what happened to the other 8 coyotes? So 6 of them we just lost track of. I believe the collars just stopped working. They may have stopped transmitting a signal. Searched for a long time looking for them and never could find those 6. One of them was hit by a car, and the damage from the vehicle collision was so severe we couldn't get data off the collar. And then the 8th one, the collar malfunctioned. It did not drop off as scheduled. As far as I know, that coyote's still out there wearing the collar. And we monitored coyotes from April 2012 to June of this year. So the causes of death, we had a total of 14 mortalities. And this is known mortalities. As I mentioned, there were 6 coyotes. I don't know what happened to them. So not counting those, we had 14 known deaths, which is a 44% mortality rate. Half of those were from vehicle collision, 7. 2 of them were from rodenticide poisoning, and I'll talk about that in more detail in just a second. 2 were from gunshot wounds. This is citizens shooting them. And 1 was conflict resolution. This was a coyote that was on Denver International Airport property, and the policy there is to remove any coyotes that go onto the property because of the damage, the risk they cause to colliding with airplanes. And then 2 mortalities were unknown because the carcasses were too desiccated to be able to determine a cause of death. So I wanted to talk a little bit more about anticoagulant rodenticides. This was an issue we discovered when we started working on the study. We weren't expecting this, and we ended up writing this paper about it. It's this short paper that's being published in Journal of Wildlife Diseases. And so I'll first go over some background of these rodenticides and then talk about how they affected our coyotes. So there's 2 types of rodenticides. There's first generation and second generation. Some examples of first generation are chlorofascinone and warfarin. And examples of second generation are brodifacoum and bromadiolone. And so for the first generation rodenticides, they're not as toxic. It takes several doses over a period of several days to kill a rodent. And the poison does not stay in the tissues of the rodent for very long. And so therefore, they're not very toxic to wildlife that eats the rodents. On the other hand, the second generation compounds, they can kill a rodent in a single dose, and they have a long retention time in the tissues of the rodent. So if a predator such as a coyote eats a rodent, he'll ingest that poison. And if the coyote eats several rodents over time that have been poisoned, the poisons will build up in the coyote system. And so they're very toxic to secondary consumers of rodents. So we ended up testing 5 coyotes that died. And the way you do this is test the livers. And all 5 were positive for the second generation compound brodifacoum. And 1 was also positive for bromadiolone, so that coyote had both poisons in his system. And we determined that the rodenticide was the cause of death for 2 of these coyotes. And so I'll talk about those 2 coyotes. The first one was at Hildebrand Ranch open space. And so this picture, this is how I found him. He was just lying there in the open space. And standing at this spot, looking towards the neighborhood, this is how close it was to the neighborhood. And so he was coming from the neighborhood, walking back towards the open space, and it looked like he just lay down and died. So Dr. Karen Fox of Parks and Wildlife and CSU did all of our necropsies, and I attended this necropsy, and when she opened him up, he just had blood everywhere in his abdominal cavity, and it was so bad she had to pick up his carcass and dump out the blood. She found a puncture wound overlying the spleen, but it was a minor wound. It should not have killed him. So it nicked the spleen, started it to bleeding, and there was no evidence of gunshot or bite wounds, so it could have just been a stick or a wire on a fence that he ran into, nicked the spleen, started it bleeding, and because the poison is an anticoagulant, the blood could not clot, and so he ended up bleeding out. And he did have a high level of brodifacoum in his system, and so we determined poisoning was the cause of his death. The second coyote was a transient coyote. I don't have any pictures of him. He was involved in a vehicle collision, but he just had very minor injuries, and it shouldn't have killed him. And again, his chest was filled with blood, and he was the coyote that was positive for both rodificom and bromadiolone. And so he had high levels of these poisons in his system, and we determined that was the cause of his death as well. So just to summarize the rodenticides, they are a contributing factor to coyote mortality. And because every coyote we tested was positive for brodificom, it's likely that most coyotes in the metro area have been exposed to these poisons. And it's not just coyotes, it'll be any predator of rodents, such as raptors. And I want to point out that these second generation compounds are most commonly used in household rodenticides, such as decon. This is the most common one. And so this is what consumers can go to Home Depot or Lowe's and buy right off the shelf. And so the EPA has recognized how dangerous these poisons are to wildlife, and so they've banned the future sales of anything containing these second generation poisons. And the makers of decon have agreed to stop selling it by March 31st of next year. But until then, what's on the shelf right now is still the product containing brodificom. So it would be a good idea to just educate citizens how dangerous these products are to wildlife. So now I'll talk about the results from our disease testing. So as I mentioned, we took blood from the captured coyotes, and we tested for antibodies to the disease, not the disease itself. This is just antibodies to the disease. And so these are the results. 84% of coyotes tested were positive for the antibodies to parvovirus, 44% for canine distemper, 28% for plague, 20% for toxoplasmosis, 4% for leptospirosis. That was just one coyote. And then overall, 88% of the coyotes we tested were positive for the antibodies to at least one pathogen. And there were no antibodies to the rabies virus found. And so these results show that coyotes are being exposed to these infectious agents, but we don't know for sure if they have the disease. These are just the antibodies to the disease. So this is just a shallow look at the disease results in coyotes. And I know canine distemper is important for dogs. Plague is important for wildlife, such as prairie dogs. But again, we don't know what role coyotes play as vectors of these diseases. And these results were written up in this paper here, which was published in Journal of Wildlife Diseases. So now I'll talk about the home ranges of the coyotes. So as I mentioned, we had 24 coyotes where we had data. Only 22 of them could I estimate home ranges for. The other two only had about 2 weeks worth of data, not enough to estimate home ranges. So that's 13 males, 9 females. I used 95% minimum convex polygon method, which is just a method that draws a polygon around the GPS locations of a coyote. And I used 95% of locations rather than 100% because some of these coyotes would make exploratory movements away from their home range, and I didn't want to include those exploratory movements as part of their home range because they're just outliers. So I used 95% of the points. I ended up estimating 28 individual coyote home ranges. 20 were residents and 8 were transients. Residents are coyotes that stay in one general area for at least one season, and a transient is a coyote that doesn't stay in one general area, he moves around a lot. So how did I get 28 from 22? So some coyotes display characteristics of both resident and transient during the time I was monitoring for them. So for example, this one here, 05F, that coyote was captured at Bear Creek Greenbelt. She had a resident home range there for a few months, and then she took off, became a transient because she just traveled everywhere. Then she came back about a few miles southeast of the Greenbelt and established a new resident home range, and so that was her second resident home range. So this coyote had 3 ranges. The other 4 listed each had 1 resident and 1 transient range. So that's how I came up with the 28 ranges. I also estimated 52 seasonal home ranges, and so by seasonal I mean biological seasons. So the breeding season is January to April, pup rearing season is May to August, and dispersal season is September to December. And we did these for residents only because we wouldn't expect transient coyotes to be affected by biological seasons since they usually travel alone and they aren't mating or raising pups. And so finally, I coded each GPS location as day or night, and then made home ranges for the day locations and then for the night locations. So I have 26 day ranges and 28 night ranges. So the next few slides are going to show you different maps of what these home ranges look like. So this is the resident home ranges. So again, this is that Denver urban area outlined in blue, and the home ranges are in pink, and they're concentrated more on the west side of Denver because that's where most of our trapping happened. And the home range size is 11.6 square kilometers for residents. And this is 20 coyotes. Transients look a lot different. They're much bigger. We had 8 of these coyotes, and their mean home range size was just over 200 square kilometers. And I want to point out this whopper here. This one is an airport coyote. He was captured at Rocky Mount Metro Airport in Broomfield, right here, and he had a resident home range for a while, and then he just took off. He went to Rocky Mountain Arsenal, he went to DIA, he went south of I-70. There's another airport here called Front Range Airport. He spent some time there, so this guy loved airports. And so this was the one that was shot on DIA property. And if he had not been shot, he was starting to establish, it looked like he was starting to establish a home range around DIA, so I think he probably would have established a residency there. And so this is just a map showing both residents on top of transients. And when I compared the two, of course, it's obvious the residents were much smaller than the transients, which is what we expect. I also looked at males versus females. So these are the resident home ranges with males in blue, females in pink. And there was no statistical difference in size between males and females. They were both about 11 square kilometers. And looking at transients, we have 4 males, 4 females. Statistically, there was no difference in size, even though the males were about twice the size of females. But again, that was mostly because of this one coyote. And there's a lot of variability in sizes, which makes them not statistically different. These are the seasonal home ranges. So breeding is in blue, dispersal in yellow, and pup rearing in red. And there were no differences in sizes, even though it looks like pup rearing would be a little bit smaller. These are the temporal home ranges, the day versus night. Day outlined in yellow and night outlined in the dark brown color. And day home ranges were smaller than night home ranges. And this makes sense because when we would go out and observe coyotes, we would see that they would be spending a lot of time in natural areas during the day, not moving around a lot. And then at night, they would go out into the neighborhoods. And so it makes sense they would have larger home ranges at night. These are the transients, day versus night, and there was no difference between those two, which also makes sense because transients don't really have a territory to settle down into during the day. So that's it for home ranges. So I'll now talk about habitat use. So I looked at 2 different variables here, land use and distance to roads. So for land use, I used a national data set called Landfire, which categorizes every pixel in the United States as a land cover category. And they used hundreds of land cover categories. And then distance to roads, I used some data from CDOT to calculate how far their coyote locations were from the nearest major road and highway. So I'll first get into land use. So as I mentioned, this Landfire data set has hundreds of categories, and I just condensed the categories into 3 broad categories. Natural is on one extreme, and that includes any kind of natural habitat, forest, shrub, grassland, riparian. On the other extreme is development, so that's low, medium, and high intensity of development in roads. And then in between is a category I'm calling altered. And so this altered category includes agriculture. We didn't have too many coyotes in ag, but we did have a couple. But the bulk of the category includes urban vegetative systems, which includes city parks, golf courses, and cemeteries. So these are lands managed for human use, but we would expect coyotes to use them more than the developed areas, but probably less than the natural areas. And then these pictures are just examples of coyotes in each of those 3 types. So the first thing I wanted to show you was a map of the Denver urban area and what it looks like with those 3 land cover categories. And so the green is natural, the pinkish color is altered, and then it looks yellow on there is development. And so the percentages are on the side. So 62% of Denver is in development, and 19% is in natural and altered each. So there's quite a bit of development as we would expect. So when I looked at land use for coyotes, I used 2 different methods, and want to make sure this is clear. So the first method is looking at the percent of the home range in each land cover type. So this is an example of a coyote's home range, and every pixel within that home range is coded as one of those 3 land cover types. The other one is percent of coyote locations in each land cover type. I don't know if you can see, can you see these dots? Well, there's a bunch of dots in here. Those are the coyote, the GPS collar locations for the coyote. So this is that same home range, but all these dots in here are coded for those 3 land cover types. So we can think of this one as being what's available to the coyote within his home range, what land cover is available, and this one as what land cover the coyote is actually using within his home range. So there's 2 different types there. And the figures I'm about to show you will show each one of those so you can see how they look for different groups of coyotes and how they differ. So I'll just show you the first couple graphs. So this is residents versus transients, and this is percent of home range. And so on the y-axis is the percentage of the home range, and these are the 3 land cover types. The dark bars are residents, the light bars are transients. And so what this is showing is that for both residents and transients, development is the highest percentage of the home range in each, it's the highest percentage of the home range. It's higher than these 2 categories. And for now, I'm just going to ignore these error bars. I'm just going to talk about the height of these bars. So that's percent of home range. The second one is percent of coyote locations. So this is what they're actually using, and it's a completely different. The highest categories are now in natural, and the lowest are in development. And I'll explain what all this means in just a minute. So that was residents versus transients. This is day versus night for residents only. And again, development is higher for night. Natural is higher for day, but that made sense because, as I mentioned, when we would go out and look for coyotes during the day, they would spend most of their time in the natural areas and then go out into the developed areas at night. So this makes sense with what we saw. And then looking at percent of locations, it's definitely higher in the natural areas for day and night. And so what this is saying is that even though they went out into the developed areas at night, they still spent most of their time at night in the natural areas. For transients, day versus night, again, development is highest is in the percent of home range. When you switch to percent of locations, it shifts a little more to natural instead of development. And so what does all this mean? So what we want to get at is, are coyotes selecting one of those 3 land cover types more than the others? And so to get at this, I'm actually running some models that I didn't have ready for the talk today. So instead, I did some more simple analyses using chi-square tests, which compare those 2 types of analyses, land cover percent of home range versus land cover percent of coyote locations. And the results of that type of analysis can tell you if coyotes are selecting or avoiding each of those 3 land cover types. And so the results of that were that for every coyote group, residents, transients, day or night, they selected natural and altered, and they avoided development. So the basic take-home message of all of this is that coyotes do have a large amount of development in their home ranges. And as you saw from that map I showed earlier, where 62% of Denver is development, they can't help but have a lot of development in their home ranges. That's what's available. So that even though they have all this development in their home ranges, they don't use it. They use natural the most. That's where they choose to spend their time within their home range. So if that's not clear to anybody, just ask me afterwards and I can explain it better. So I also wanted to show a couple of graphs here. So on the x-axis is percent development in the home range, and on the y-axis is home range size. And so I wanted to look at if when development in the home range increases, does home range size also increase to accommodate that extra development? And as you can see here, there's absolutely no relationship. The line is flat, which means there's just no relationship between the 2. Same thing with percent altered in the home range on the x-axis. The line's a little bit bigger, but still there's no relationship between the 2. So home range size does not increase as percent development or percent altered increases in the home range. So the second habitat variable I looked at was distance to roads. And again, this is just looking at the distance of each coyote location to the nearest major road or highway. And there's really nothing interesting here. No difference between residents and transients. They were both about the same distance from roads on average, about 350 meters. Now looking at day versus night, again, no differences for residents or transients between day and night. So once I looked at these two habitat variables, I noticed a pattern, so I wanted to bring that up. So the 4 coyotes with the smallest % of development in the home range are those 4 listed. And then the 4 coyotes with the largest distance to roads, meaning they're farthest from roads, are those 4 listed. And so there are 3 of those coyotes are in common. And so those 3 coyotes are NREL, South Table Mountain Coyote, the coyote we had at Ken Carroll, Willowbrook neighborhoods, and then this airport coyote I mentioned earlier. And so those 3 seem to be what I'm calling less urban because they have less development in their home range. They tend to stay farther away from roads. And most of our coyotes I would consider urban, but these 3 I would just consider less urban. So I just wanted to point that out. I also wanted to compare our results to a couple of other urban coyote studies, specifically Chicago and Los Angeles. So in both Chicago and LA, when they looked at % of home range, their highest percentages of coyote home ranges were in natural, and ours, the highest, was in development. So that's one difference. They also had a few coyotes that had no natural or no development in their home range. Chicago had 8% of their coyotes had no natural, and LA had 22% had no development. But in Denver, every single one of our coyotes had all 3 land cover types in their home ranges. And then finally, those graphs I showed you where the line was flat, both Chicago and LA, when they compare % development to the home range size, their line just went straight up, which meant as % development increased, home range size also increased to accommodate that extra development. So having development in the home range for those coyotes affected their behavior so that they had to increase their home range size. But in Denver, we just didn't see that. So now I'll get into the diet study that we did. And so these are just going to be preliminary results. We haven't analyzed everything yet, so I'll just tell you what we do know. And so we examined diet by collecting coyote scats along 12 different sites. And the sites were divided into high housing density locations and low housing density locations using those definitions. And we analyzed diet seasonally. So I just want to, I figured this would be hard to see, but it's zoomed out so far it's hard to tell, but these are the 6 high density sites. And so there's 3 in Broomfield at Ridgeview, the Field, and Metzger, 1 in Thornton, which is East Lake, and then we have 2 in Jefferson County, Crown Hill, and Moffett Water Treatment Plant. So those are the 6 high density sites, and then the 6 low density sites. We had 1 in Erie, 1 in Broomfield, Anthem neighborhood, South Table Mountain, Green Mountain, some trails near the Ken Carroll neighborhood, and then Hildebrand Ranch. And so what we did, we go out every month and walk a transect that we predetermined. We walked the same transect every time and collected any coyote scats we found. And so I have a table for the results for high density sites, and then the next slide will show the table for low density sites. And so what we're doing here is dividing the months up into seasons. And so this is early spring, late spring, summer, early fall, and late fall. And we don't have January and February because we didn't have enough scats collected in those months. And so we have 4 broad categories here: seeds or plants, bone, hair, and this anthropogenic category includes trash, such as papers, is just junk that was found. And then all of these percentages are based on weight of the food item in the scat. And so this column here is the weight of the scat that did not contain any food items. And so, of course, that's going to be the biggest percentage. And so for the high density sites, the biggest percentages were in bone and hair, smallest percentage in anthropogenic, and then 2.6% in plants. For the low density sites, it's kind of similar, still high percentages in bone and hair, small percentage in anthropogenic, but 11.4% in plants. And so comparing the 2 sites, as you saw, there was a higher proportion of diet in plants in the low density sites. The anthropogenic items were slightly higher in the low density sites, but it was such a small percentage that it was just a trivial difference, so it probably wasn't statistically significant. And then there were more hair and bones in the high density sites, about 9% more. And so of those 4 categories, plants, bone, hair, anthropogenic, the only one we've analyzed in detail are the plants. So I don't have animal data to give you. I can't tell you what animals they're eating yet, or pets. I don't know about that yet, but that's coming up soon, hopefully. So for the plants, the highest frequency of plant species in the high density sites were Russian olive, field bindweed, and cactus. And in the low density site were Russian olive, corn, and cactus. So in each of the 2 types of sites, 2 of them were non-native species, with cactus being the native. And so we had a total of 23 plant species found in scats. 9 were native, 14 were non-native. Some of the native examples were a lot of the berries, so chokecherry, ground cherry, plum, wild grape, raspberry, of course cactus. And then the non-native, we had crops and invasives. So crops included corn, alfalfa, oats, wheat. There was watermelon in the scats. Some of the invasives were just several species of weeds, dandelion, and then of course the Russian olive. And so the fact that we found 9 native species in the diet of coyotes suggests that they may be pretty good dispersers of these native species. So before I move on, I had one other story on diet. So we did find a microchip in a scat, and this microchip was traced back to a domestic cat. And so we had to call the owner of the cat and tell her that her cat was eaten by a coyote. So that's all I know about pets for now. Okay, so finally, we wanted to give you an estimate of coyote population size. And I want to emphasize this is an estimate only. There's a lot of variability in these numbers, as I'll show you in a minute. And so this is just a really rough estimate. So I'll first go over briefly how we did this, and then the next few slides I'll go into more detail. So we took that Denver urban area polygon that I've been showing you, and we subtracted out the most highly urbanized areas, and that remaining area was divided by the average home range size of residents to get an estimated number of packs. We then got an estimate of coyote pack size. And so we're going to give you 2 different estimates, one for winter, one for summer. Winter includes adults only, and summer includes adults and pups. And so we then take the number of packs, multiply it by pack size to get the number of residents, add on a certain percentage for transients, and then you get the total number of coyotes. So let's just go through each of these. So this is that Denver urban area again, outlined in blue, and the green spots, the green places are what we included in the estimate. So anything in white was removed. So for example, we removed the downtown area here, and then all of these other white spots were also removed. And we ended up removing 27% of the Denver urban area. So I wouldn't expect coyotes necessarily to use downtown, but I might still expect them to use some of these highly urbanized areas. So the estimate we're going to give you might be conservative by about 20%. So just keep that in mind when you see the numbers. It might be conservative by about 20%. So the area of the green is 1,289 square kilometers. We divided that by the average home range size of residents, and I showed you this map earlier of the home ranges of residents, where the mean was 11.6. So you divide 1,289 by 11.6, and you get a mean number of packs of 111.5. And so this is where the variability starts to come in. So you can see some of these home ranges are really small, and some are pretty big. And so there's just a lot of variation in home range size, so we wanted to incorporate some of that. And so the estimated range of home range size are these numbers here. So if you take that 1,289 square kilometers of the Denver urban area and divide it by each of these 2 numbers, you get an estimated number of packs, the range in this range here. So that's the number of packs. So the next thing we did was estimate pack size. And again, we had 2 estimates, one in winter, one in summer. And the winter estimate is based on other urban coyote studies. So this is just people going out and seeing how many coyotes are in a pack. And the mean that we're using is 4 in a range of 2 to 6. For pups, the way we estimated these was I did some den monitoring in summer of 2013, where I set up some cameras at den sites and then counted the number of pups in the pictures. And so based on those pictures, the mean litter size was 4.4. And so I took the 4.4 pups plus the 4 adults to get a mean pack size of 8.4. And then those are the ranges there. Again, there's a lot of variability in these pack sizes. So just to show you these pictures, this was at Moffett Water Treatment Plant. They had 3 pups. Pete showed you this picture. It's of the Bear Creek Greenbelt where they had 7 pups. And then this is a site in Thornton called Lambertson, and they had 6 pups. There's only 4 in that picture. And so finally, this is my last slide, and I can keep this up if anybody wants to look at the numbers. So the first row is number of packs, the 111.5 with the ranges. Oh, come on. Oh, I think it's dead. Oh, there it is. So that's the number of packs. The pack size in winter, as I mentioned, was 4, in summer 8.4. Multiply these numbers out, you get number of residents in winter and summer. And then for transients, based on other studies, I just added 15% of the adults and called those transients, so that's 67 transients. And then these are the final numbers for winter and summer. And again, lots of variability here. These ranges are huge because of the variation in home range size and the variation in pack size. So that's it. Wait, I have an announcement. So I have an announcement. There's going to be an urban wildlife conference next spring in May in Chicago. If anyone's interested, I put some flyers back here on the table. If I'm actually co-organizing a symposium on carnivores, so if you're interested in presenting a paper on carnivores in urban areas, you can come talk to me. Otherwise, if you're just interested in attending or submitting a paper on anything else, the information's back there.
Let's do a 10-minute break.